All right, guys. Welcome to our first really video of e-learning. So we're gonna we did have this. We are skipping that. So we're not really gonna worry about this for right now. Okay, we're gonna go into our solving. That other one was just more with graphing and horizontal asymptotes and vertical asymptotes. Okay, so we're gonna look at our some of our solving stuff, solving rational equations. And we solve rational equations very similarly to how we added and subtracted. So we will get a little more practice with that. And we want to get a common denominator, and then we just solve our numerators. So the first thing is extraneous solutions. Extraneous solutions really are solutions that don't work. We've kind of seen them before. In the case of rational expressions, they are solutions that make a denominator equals 0. Okay, so in the course of our work of solving one of these, we get we get rid of our denominators. But at the end, we have to remember where we came from, and if we divide by 0, it's not possible. So we do want to make sure we aren't getting anything that is going to make that denominator 0. Okay? So we still want to start the same way as we did before. I want to look at my denominators, and I want to get a common denominator. So here I have 4. Right? So I'm going to break them down the same way. And here we have 4x, which equals 2, right? So in the same way, we're going to get that common denominator, right? So our least common denominator is 2 times 2 times x. So in our first variable, I have x over 2 times 2. And what am I missing? I'm missing this x. And x times x is x squared over that denominator. In our other function, we have 9 over 2 times x. And if you notice, we're not missing anything, so that's good. So now what I'm going to do is, now that I have a common denominator, I can ignore it. I get x squared equals 9. Okay? And then I'm just going to solve for this. It's a quadratic, so I have to get it equal to 0. This is our difference of squares. So I get x plus 3, x minus 3 equals 0. I'm going to solve these two things separately. I have x plus 3 equals 0. X equals negative 3. And then I have x minus 3 equals 0. And we get x equals 3. Okay. So those are our two answers. Now I want to check them. If I plug in negative 3, well, there's no x here, so it's not going to affect this one at all. If I plug negative 3 or 3 into 4x, it's not going to make it 0. So I do not have to worry about any of these being extraneous. Okay? All right, looking at B, we have x minus 3 over x plus 5 minus x over x plus 2. Well, this should be fairly simple, as we have x plus 5 just equals x plus 5. It's linear, it has no common factor, so there's nothing I can do there. And x plus 2 is just x plus 2. Again, it's linear, there's no common factor. And then we do not have to worry, there is no denominator with 0, so we do not have to take it into account for our least common denominator. So I have x plus 5 and x plus 2. So my least common denominator is x plus 5, x plus 2. So now I have x minus 3 over x plus 5. Well, it's missing that x plus 2. Remember, we have to distribute here. So I have x times x is x squared. X times 2 is 2x. Negative 3 times x is minus 3x. And then minus 6, which is x squared minus x minus 6 over our denominator. Okay. So we have x squared minus x minus 6 over x plus 5, x plus 2. Same thing with our other denominator. I had x over x plus 2. Well, if we look here, right, we're missing the x plus 5. So again, multiplying, I have x squared plus 5x, right? I'm just distributing that x. I can do the same thing with this 0, or I should. The only reason it's not really going to matter is because it's 0. So let's look why. 0 currently doesn't have a denominator, so it needs both the x plus 5 and it needs the x plus 2. Well, this is super simple, because 0 times anything is just 0. Okay. Now, all of these have the same denominator, so I'm just going to set it up as if I'm solving it. So I'm going to take this first one. I have x squared minus x minus 6 minus my second one, x squared plus 5x equals 0. Okay? So as soon as you have a common denominator, you drop the denominator. You don't need it anymore. So I'm going to switch my signs, right, because it's a subtraction. So that's plus. This is minus and minus. Let's combine our like terms. We have x squared minus x squared. Those cancel. Negative x minus 5x is negative 6x. And then we have minus 6 equals 0. Okay? This is different. This had a squared. This does not. This is just simple solving, right? I'm going to add 6 to both sides. And I'm going to divide by negative 6. Okay. Now, I want to plug it back in to my denominators. Negative 1 plus 5 is 4. Good there. Negative 1 plus 2 is 1. I'm good there. Okay, so as long as your denominators aren't 0 at the end, your answer works. Let's look at another example. Let me scroll here. So I'm going to do the same thing. I'm going to start by finding my least common denominator. So I have a 3x. I have 6, which equals 3, and then times 2, which I'll throw in at the end, and then another 3x. So for my LCD, I have a 3. I have an x, and I have a 2. Okay. So making my fractions all have the same denominator. I'm going to start with my first fraction. I have 9 over 3x, 3 times x, right? And it's just missing that 2. One over 6, which is really 1 over 3 times 2. Well, it's missing this x here. And our last function, 4 over 3 times x. Again, this last function is also missing that 2 right here. So yeah, they now all have the same denominator. So I'm going to rewrite this, but I can ignore the denominator. So I have 18 plus x equals 8. Sorry, guys. So we have 18 plus x equals 8. That's all right. So now, again, this is not a quadratic. There is no squared. When it's not a quadratic, you're just doing normal solving, do opposite things to get x by itself. So here's x, it has an 18 with it. I'm going to subtract 18. Right, x equals negative 10. Okay, that's it. Then again, we want to check. Our original denominators were 3x, 6, and 3x. If I plug 10 into any of those, it's not going to make them 0, right? The thing we wouldn't want would be like x plus 10, like the opposite of it, right? Last example. We have 4 over x plus 1 equals 2x plus 2 over x. This one's nice and easy with our common denominator, okay? This is just x equals x, right? There's nothing to just split up there. And 1 doesn't have a denominator. So really the only fraction I have to fix is 1. But I'm going to kind of show all of them, right? So I have 4 over x. It's already good. I have 1 over nothing. It's missing the x. Which gets us to 1x over x. And then we have that 2x plus 2 over x, which already has the x. They all have an x on bottom. They are common. So I have 4 plus 1x equals 2x plus 2, right? As soon as they all have a common denominator, you no longer need the denominator. Now I'm solving. I have an x in 2 spots. I have an x here and an x here. I need to get rid of one of them. It doesn't matter which one you get rid of. So I'm going to get rid of this 1x by subtracting it. Now x is here. I'm going to subtract 2. So x just equals 2. And that's it for solving, right? Getting your least common denominator and then solving the equation that comes out of it, okay? There is an activity for you to practice on Delta Math. You should be practicing still. We are hoping to come back after spring break and we'll have this test pretty much right when we get back. So you do want to be practicing these things so that you are ready for that. Otherwise, have a great rest of your day.